how could they take their data from a blinky car and make a graph with it? Well, first of all, you'll need to open up Sheets, and then we'll have to make a data table. I made the first column to represent our independent variable, the clock reading, which was measured in blinks, and I went ahead and numbered that from 0 to 8. And then we would have to run the experiment, let the car run across the floor, mark the position on the floor, and I just used a general term tiles, as in maybe just some tiles that were set on the floor that were all the same size. And we made sure that the first blink occurred right when the tires were at the end of a tile, and so it was 0 tiles. One blink later, the car had moved approximately 0.6 tiles. At 2 blinks later, it moved approximately 1.2 tiles, and that continued all the way out to the 8 blinks. So make sure that you record your clock readings and your relative positions here. At this point, to make a graph, you simply highlight the 2 columns you would like to include and go up to Insert. Now, even though we're inserting a graph here, Sheets asks us to use a chart, and we'll go ahead and click Chart. Now, usually this pops up and is way too big for the area. So hopefully that'll jump in there and we can see it now. So the first thing I'm gonna do is I'm gonna scrunch it down just a little bit, if it'll let me. So we're gonna shrink that down and make it into a smaller space, and then I'll go ahead and pull it so it's next to the data so we can see both the data as well as the graph at the same time. I think I still want it to be a little bit smaller, so I'm going to click on that, and let's see if we can shrink it this way just a little bit. See if we can get that all in one screenshot. And a little more. So now that we have created this chart in here, we can see both the data table, which has still our clock readings and positions in it, and we can also see the corresponding graph. Notice that what was originally in column 1, the independent variable, the clock readings, ended up on the x-axis. Secondly, the positions, our dependent variable, ended up on the y-axis, and for each of those we have both the label and the units, and the title for our graph should always follow what's on the y-axis versus the x, so it's position versus clock reading. Now, this kind of graph is a line graph, and because the data I picked was created, I made it up, it turned out pretty perfect. However, you can do other kinds of graphs, and frequently what we're going to need to do is click Setup, and instead of a line graph, you could pick a scatter plot, which would look more like this, in which case you can see the data points. If necessary, we could draw a best fit line or do some mathematical calculations to find the steepness of the slope, or specifically what the y-intercept is. We learned earlier today that for a position versus time graph, that the y-intercept, where this line crosses the y-axis, tells us the position when time equals 0, or the starting position. So this object starts at a position of 0. The fact that the slope is constant tells us that the speed is constant. The fact that the slope is positive reinforces that this blinky car was moving in a positive direction. So the blinky car started at a position of 0. It moved in a positive direction at a constant speed. I hope this helps.